from this point right here, 3, 1, to this point down here, 1, 4. What type of changes would have had to happen to our graph? Or how would our graph have shifted to get from the point 3, 1 to the point 1, 4? How would we have had to move?
Left 2.
Negative 2. Yeah, left 2. Okay, good. So left 2 places. And how else would we have had to move? Up 3. Good. All right. So we were able to describe that in words. Now they want us to write this like it would look in that transformation type of equation. So basically like how they wrote it on these examples right here. That's how they want us to write it, okay? So to get from f of x to g of x. Okay, so we would have, oh, I wrote that on the wrong line. I'm sorry. Left 2 and up 3. Okay, so to get from f of x to g of x, you guys said left 2, and what would that look like inside of the function? Plus 2, good. So we'd have f of x plus 2. And then how would we show that we moved up 3? Plus 3 out there on the end. And that would result in getting us to g of x, right? That would get us to that point at g of x. Okay? Part F asks the same thing, but in reverse. So now they're asking, how could we have gone from 1, 4 to 3, 1? So how would we have made that happen? To the right, and, okay. So here, the way we would express that would be to say that if we go 2 to the right, in that parenthesis, I'm going to put minus 2. And to show that we went 3 down, we'd also put a minus 3, right? And that should get us to f of x. Nice. Okay. For number 4, it says that the absolute value parent function has been transformed to make this graph shown over here on the right. So remember, the parent function, we drew it on the front. It started at 0, 0, had a slope of 1. So if you want to draw it on here, feel free to do so, just so it's easy to make a comparison. Okay, so the blue one is the parent function. The one that was already on there in black is the transformed version. Okay. It says describe the transformation in words. So how would I get from the blue graph to the black graph? What would have to happen? What changes were made to get from the blue to the black? The assignment?
Yeah,
okay. Okay. So what changes were made, guys, to go from the blue graph to the black graph? What's different about them? It was reflected over the x-axis. Very good. So reflects over the x-axis. What else we got? Good. So left, how many places? 4, okay. And up 2. Very good. So they then want us to take that information and write what the new equation should then be. So if I reflected over the x-axis, does that go where A, B, H, or K goes? The A value, right. And what do I put to denote that it reflected? Negative. So where A goes, I put a negative. This is an absolute value function, so I'm going to put the absolute value bar. Do we have to put anything for B? No. Okay. So then I just need to write the part for H. What am I going to put in there with X for the H value? Plus 4. So I'll have X plus 4. Close that absolute value. And then outside, I would put Nice. Okay. Part C says, if you move the function in part B, so the one that we just wrote right here is what they're referring to, 5 units to the left and reflected it over the y-axis, what would be the resulting equation? Okay, so let's see if we can come up with what that equation should look like. All right, so they didn't say to change anything about A, did they? No. So that stays a negative. But did they give us something that we should be plugging in place of B? Of B? Over the y-axis. What do we have to put to show that we reflected over the y-axis? A negative. Very good. So I got to have a negative in here too. You can put -1 or just negative. Okay? And then in the parentheses, this part's going to change too, right? Because they said that we are now going to go 5 units further to the left. So we had already gone 4 units left. Now we're going to go 5 more. So what would it be now? +5. So we were 4 units to the left. 5 more would put us at a total of 9. Good. And then they didn't say to change anything about the up and down shift. So that part will stay a +2. And it says if you wanted to check your answers, you could go and put this in your graphing calculator. Put like this equation in y1 and this equation in y2. And it should change exactly how they described. Okay, so it should flip across that y. And it should have shifted a little bit further to the left. Okay. All right, flip it over onto that last page. So it says here that the function f of x is described in the table is transformed so that it appears as shown in the graph. All right, so it says, describe the transformation from the table to the graph in words. So describe how we would have gone from here to here in words. Okay, well, you might want to graph those coordinate points so that you can see what's happening. So let's go ahead and plot these points. We got a point at -4, +1. Oops, -4, +1, -3, 0, -2, -1, -1, 0, and 0, 1. All right, so your function looks something like this. They want us to describe what would have had to happen. So what happened to go from the blue to the black? Yes. Reflected, yeah, flipped or reflected. Over which axis? Good, okay. So reflects over the x-axis, nice. What else we got? So remember, the blue graph came first. So the blue graph came first, so it actually moved to the right. Right, 2 places. You are correct about the number of spaces. And then did it go up or did it go down? Up how many? Okay, so remember, guys, if I were to flip it over, then my point would stay as is, right? So the way he came up with 5 is he just counted how many spaces between, right? Okay. All right, so if I were to reflect across the x-axis, though, something we need to keep in mind is that if I am currently, let me draw this line in green to show where the x-axis is. If I'm currently one place below, right? If I were to flip over that axis, then I'd be one place above, right? And then I'm going to make my shifts, right? So if that's the case, then I actually would only have to shift up 3 places. All right, so then it says to describe this transformation in the actual notation, like what we saw on the previous page. So to get from our table, which we'll call f of x, to our graph that was in black, we'll call it g of x. You guys said we would reflect over the x-axis, which goes where a goes. And then we said we would be shifting to the right 2, which would go in here where h goes. And then we'd have our plus k out there on the end, right? Okay. It then says they want us to write the equation for the table. Well, in the table, which point was our vertex? -2, -1. This one right here. Okay, so your vertex was -2, -1. So if you're going to write your equation, or I guess this one's f of x because it's the first one, sorry. F of x is equal to now on the original we would assume that no changes have been made to a or b, right? Just some sort of a shift. So inside that parenthesis we'd have our x plus 2 for the h, or not inside the parenthesis, inside the absolute value. And then on the outside, we'd have a plus 1 for our k value, right? So then they want us to write the equation of the graph shown over here in black. Well, here its vertex was at where? Where was the black graph's vertex? 0, 4. Okay. And on top of that, we said not only did the vertex move, but it also was reflected over the x, right? So when we write this equation, those are the 2 things we keep in mind. So to show that it reflects over the x, what would I need to put first? A negative. Times the absolute value of, in this case, do I need to put anything in there with h? Because the h value is 0. So I'm just going to put an x in there. You can put plus 0, but it doesn't have to be there, right? And then on the end, we'll put plus 4. Yes?
For C, would it be -2?
-2.
No, subtract 4.
Oh, yes, at the end. Yes, that should be. Thank you. Thank you for catching that. All right. Okay, in the last section down here, it says describe the transformations on each parent function. So you're just going to go through the list, and I want you to write down what type of parent function it is first. We should be able to tell what type of parent function it is based on if it's linear, quadratic, or absolute value, because we know what those look like, right? We know that a linear function is just going to have the letter x. We know that a quadratic should have x squared, and the absolute value will have absolute value bars on it, right? So on number 1, what would the parent function be for that one? Linear. So you can write that to the side. And then we're just going to describe the changes that happen. So for this one, what do we see in the a value place? a -3, right? So what does that make happen? Reflects over the x-axis. Very good. And what does the 3 do? What did we call that? When it's a number larger than 1, what do we say on the front page? Vertical stretch. Very good. So we have a vertical stretch by 3. Okay. Do we seem to have anything for an H value on this one? Do we seem to have anything for a B value? Okay, so we don't have to worry about H and B. Do we have anything for a K value? Yeah. What is our K value? Which means what? Good. Okay. All right, so I want you guys to try 2 through 6, writing down what the parent function is, which is what we wrote here, and then describe the transformations for me. So you may need to flip back to the front page to see what some of those things are called if you don't remember. Yeah. Make sure though that you're ready to go guys and test on Wednesday. So this one is a linear, so the part in the top would be your A, the part in the bottom would be like your B. But if you want to use 2/5, because linears are a little bit different, right? Because there's just the single line. If you want to use the whole 2/5 as an A value, it works the same way. Yeah. Okay, so I have a good question about number 2. First of all, what type is number 2? Linear. Good. Okay, and because it's linear, it does work slightly different, right, than our other functions. Because a linear function is a single line, while our quadratic or absolute value has another side to it, right? So you guys probably saw whenever we looked at that one example on Friday that even though we had shifted like left or right and up or down, really the only part you notice is the up or down, right? Because there's another point that just comes in and replaces it, right? So that's also true with your slope, right? Or your A value. Okay, they would probably want to separate it if there was going to be a specific B value. I had someone ask if the top number was A and the bottom number was B. Not necessarily in this particular case. Although we did say the top is the rise and the bottom is run, we can just consider that entire 2/5 our A value and describe it in that way. Okay. So if 2/5 is our A value, what would we say is happening?
Vertical compression.
Right, very good. All right, did we have an H value on this one? Yeah, what was our H value?
Plus
1, which meant right 1. Good. And did we have a K value?
Yes.
And it told us to move.
Down 1.
Very good. Okay, what about number 3? What was its parent function? Quadratic, right? How do we know?
X squared.
Right, perfect. Okay, so this one's quadratic. Did we have an A value on number 3? Yes, what was it? 2. Okay, so what did that mean was happening? Vertical stretch, very good. All right, now our understood B value here is just 1, right? And is B gonna change anything if it's 1? Okay. Do we have anything for an H value that would change anything? What about K? Yeah, what's K gonna change?
It's going to go down.
Very good. Okay. All right, number 4. What type of parent function was number 4? Also quadratic. Good. All right, did it have an A value that would change something?
Yes.
Yeah, what was its A value? -1/2. Okay, so the negative does something and the 1/2 does something. What are those two things?
X over the x-axis.
Very good.
Vertical compression.
Nice. All right. And then did we have anything for a B value that's going to change anything? No. What about H?
Yes.
Okay. Which means it's going to
Left 4.
the left 4. And then anything for K? So it's going to move. Good. Okay. All right, what kind of parent function is number 5? Good. All right, does this one have anything for A that's going to change our graph? For the A value, it would be 1/2. And what does that 1/2 do? Vertical compression. Good. All right. And then I heard you say that it's going to go left 3. That would be because of the H value, right? Okay. So left 3. Anything else?
And then
Good.
down.
So that means there was no B value worth changing anything, right? Okay. Last one. What is its type? Absolute value again. All right, does it have an A value that will change our graph? Yes. What's our A value? Okay, and what's that negative 3 going to make happen?
Reflects over the x-axis and also vertical stretch.
Good. So reflect over x-axis and vertical stretch of 3. Okay. All right, what about B value? Does this one have a B value that's going to change anything? Yeah? Negative 1/3. What does the negative do? Reflects over the y-axis. So I'm going to add that up here. I'm going to say it reflects over the x-axis, and it also is going to reflect over the y-axis. Okay, now the B value, remember, is going to do the opposite of what we think it would do, right? And it also changes things horizontally. So horizontal stretch, yes, So we would think because it's a 1/3 that it's a compression, but it's actually a horizontal stretch. Okay, and remember the way that we find what value it is stretching or compressing by is it's the absolute value of 1 over B, right? So if you were to just look at this part, we know we're going to keep change flip. So this actually ends up just being 3, right? Okay, and H value that's going to change anything? The 2, okay, and that would shift us how? Right, 2. And then our K value is going to shift us up 5. Nice. Good job. Okay.